So in this video we're going to look at using some methods to try and predict what substances will be formed. If you look at typical exam questions, you can see that you're given a range of compounds and you're asked what will be formed at the different electrodes. So we're going to use three rules that are shown down the bottom here to try and do this prediction. First of all, we're going to make sure we understand the terms used in the rules, and we're just going to look at a quick bit of background. If you've got a beaker here and we've got an electrolysis set up with positive electrode, negative electrode here, the important thing to understand is that there's a flow of electrons around here in this direction towards the negative, and this is kind of a circuit, but part of the circuit here is a liquid, and for electrolysis to be able to work, the ions must be free to move in the liquid. So it will only work on substances with ions in and substances with liquid ions, so it will not work on solids. So if we were to look at what happens if you've got a negative electrode, of course the positive ion will be attracted because opposites attract, opposite charges attract, and we can say then that the copper will be reduced and will form solid copper. And if reduced means gain of electrons, you can see here's the copper ion, it gains 2 electrons and it forms the element copper. Here the chlorine ion will be attracted to the positive electrode, where it will give up its electrons. The electrons will flow around here, so we can show that the chlorine becomes oxidized. It loses 2 electrons to form chlorine gas, the element. So one of the rules we just saw here, rule 1, says the halogen goes to the positive electrode. Now halogens are group 7, and they also include iodine, and they've all got 1 negative charge. The second rule talks about positive ions and reactivity. So we need a bit of background on reactivity of metals, and you can see the most reactive at the top here, potassium, going down to platinum, and also included is hydrogen, and that's going to be important when we look at electrolysis of aqueous solutions. Our third rule mentions complex negative ions, and complex just means an ion with more than 1 atom in. Chlorine here has only got 1 atom in, but nitrate has got 1 nitrogen, 3 oxygens, so we call the nitrate ion a complex ion, and also the sulfate ion we describe as being complex. Now it says aqueous solutions here, so we need to know that an aqueous solution, the aqueous of course means water, dissolved in water, and water always slightly dissociates or falls apart to make a hydrogen ion and a hydroxide ion. So wherever we have something dissolved in water, we've also got these 2 ions present. So we said that you could be given a range of substances, a range of compounds, and you need to try and classify these, and you've got 5 different descriptions here, and we're going to try and match these up one by one to predict what will react and what will be formed at the 2 different electrodes. So first of all, we're looking for solid substance. So if we look at our state symbols here, we've got solid, aqueous, liquid. So our first one, a solid ionic substance, here is sodium chloride. So we've got these ions present, but because it's solid, the ions can't move, so we don't get any completion of the circuit here, so electrolysis does not happen. Next we're looking for a molten ionic substance. So since these 3 are all aqueous, which means there's water present, this must be the molten one. It's a liquid sodium chloride. So we can say that the sodium chloride, these ions are present again, only these ions, and this time the sodium is attracted towards the opposite negative charge on the electrode. It will gain an electron at this electrode and it will form the element sodium. At this electrode, chlorine will be attracted here, it will lose an electron and it will form chlorine gas. Of course you'll need 2 chlorine ions to form the Cl2 molecule. So next of all we can see we've got these three substances, and I've lined these up by accident here. We've got metals that are more reactive than hydrogen. So if we look at our reactivity series, we can see that sodium is more reactive than hydrogen, copper, yeah, less reactive than hydrogen. So copper, less reactive, sodium, more reactive. How did we know which one went in these two? Well, this is the one with the complex negative ion. Sulfate is the complex negative ion. So, sodium chloride, aqueous. These ions are also present now from the dissociation of water, and we need to try and apply the rules to work out what's going to react and what is formed at each electrode. So it tells us that the halogen goes to the positive electrode. Yes, well, we've got our halogen here, we've seen that, it's the same as above. Our most reactive positive ion stays in solution. The most reactive was sodium. We said that sodium is more reactive than hydrogen, so the sodium stays in solution. The hydrogen is what reacts at the negative electrode and will gain an electron from the negative electrode and can then form the hydrogen molecule. Those electrons are used to form a covalent bond between two hydrogen ions to bond them together into a hydrogen molecule. At the other electrode, same as before, chlorine ions form chlorine, the element. So we've got copper chloride. What is important now is this rule again, rule 2, the most reactive ion stays in solution, and we said that hydrogen is more reactive than copper, so it's the hydrogen ion that stays in solution this time. So it's the copper that reacts at the negative electrode. So the copper reacts, it forms the element copper because it's gained 2 electrons, and the same again at the other electrode, chlorine ion, chlorine gas. Finally, if we look at our third rule, we've got a complex negative ion. The complex ion stays in solution, and this time it will be oxygen that is formed because it's the hydroxide that is attracted towards the positive electrode, and the hydroxide gives its electron out and forms oxygen. Okay, so we've classified our 5 substances here. I suppose that's the tricky bit, and then you just follow the rules to work out what's happening over here. And for you to practice doing that, we've got 5 different ionic compounds here, and if you can go through the rules, try and work out what is going to be formed at the 2 different electrodes. Okay, good luck.